Well, as a frequent dinner speaker and a lover of the grape, one of my challenges is to stay one drink behind the guests. I think I've managed to do that tonight. I'm going to give you a glimpse into this book, Fake Invisible Catastrophes and Threats of Doom. I can't do it all, but I hope I can give you a thumbnail. Of course, the greening of the Earth is probably the most important thing for people to understand about CO2. There's lots of other important things too, but this is the fundamental way to show people that carbon dioxide is good, not bad. This is where I grew up. I grew up on a floating logging camp on a far-flung inlet on the northwest coast of Vancouver Island in the rainforest by the Pacific. There was no road to that town. I had to go to school by boat till grade 8. And when the road came, we thought the place would boom. Half the people used the road to get out. It was the mid-1960s and into the late 60s when I discovered the science of ecology. It was also the height of the Cold War, the Vietnam War, and the threat of all-out nuclear war, and the emerging consciousness of the environment. Whoops. I turned into a radical environmental activist during that period. That was the hippie era. I was actually a PhD student in ecology, but also a hippie at that time. And I can't seem to get it to go that way anymore. We planned and sailed a protest voyage against US hydrogen bomb testing in Alaska in 1971. I was on board that boat for many weeks as we gained notoriety on Walter Cronkite and caused thousands of people to march in the streets at the height of the Cold War. And it actually worked. We went up against the world's most powerful organization, the US Atomic Energy Commission. And shortly after our voyage, President Nixon canceled the remaining H-bomb tests, signaling the beginning of the talks between Russia and the United States over the reduction in nuclear weapons warheads. So that was our first campaign, and we had a good victory on it. We turned our attention next to French atmospheric nuclear testing in South Pacific. France was still detonating atomic and hydrogen bombs in the atmosphere in the early 70s, sending radiation around the world. It took 2 years of campaigning, again sending boats in to act as a spearhead or point of the spear against the campaign. We went to Notre Dame and pamphleted the people there. We said we'd stay in Notre Dame overnight, but the police came and told us it wasn't a church, it was a government building, and so we better get out of there. Oh, so we did. We were always fairly practical in Greenpeace. I got arrested 3 times but never spent a night in jail because we always had a good lawyer. Anyways, France ended those atmospheric nuclear tests within 2 years of our beginning that campaign, and that too was a great victory for us. Well, we'd pretty well stopped nuclear war by this time, so we had to turn our attention to something else, and that something else was the fact that 30,000 great whales were still being slaughtered every year on the high seas, primarily by Japanese and Russian factory whaling fleets. So a whale scientist who'd studied whales came to us and said, "You guys are the only environmentalists who know how to go out in boats. Everybody else is just walking on the street with a sign. So you got to go out and save the whales." And there I am driving a Zodiac with my late friend Fred Easton, the cameraman, in the first encounter with the Soviet factory whaling fleet. That's the factory ship in the middle with 2 of the killer boats. There was about 16 of them. And we sidled up there to the boat and started taking pictures. And they thought we were hippies from California because this was off San Francisco. Maybe I don't know what they thought we were doing, but we went up to them to offer them some gifts of blue jeans, ballpoint pens, and Playboy magazines. They told us this is what Russian sailors would want. And the guy leaned down and said, "Hey, you guys got it any acid?" Then we got serious. That's me getting out in front of the Russian harpoon to protect the fleeing whales. It was quite a scene. And this got us on television around the world. Greenpeace had been known for its anti-nuclear campaigns, but this really did it. And we started making a lot of money, and we started getting very famous and being wanted all around the world at this point. It took 4 years of campaigning to end that factory whaling in the world. Here I'm sitting on a baby seal off the east coast of Canada. This was the 3rd year of that campaign to stop the slaughter of 250,000 nursing seal pups on the ice floes off the east coast. It wasn't because they were going to go extinct like it was with the whales. It was because it's just not right to bludgeon the babies of wild mammals by the hundreds of thousands while they're still nursing on their mother. So we stopped that, and it took 4 years to do that. Anyways, a long time went on. After 15 years, we founded Greenpeace International. I was one of the directors for the last 6 years. Why did I leave Greenpeace? Whoops, how do I go backwards here? Why did I leave Greenpeace? 2 reasons are the main ones. First, at a philosophical level, Greenpeace had started with a strong humanitarian orientation to save human civilization from nuclear war. That meant we actually liked people. That's the peace in Greenpeace. The green, of course, was the environment. Someone said, let's make it a green peace. And that worked. The other thing, though, which was much more pointed, was by this time, none of my fellow international directors, 6 of us, had any formal science education. They decided, with my protestation, to start a campaign to ban chlorine worldwide. I said, you guys, this is one of the elements in the periodic table. It is like one of the building blocks of the universe, you know, this place we live. And also, they didn't notice that there was such a thing as table salt, I guess, which is sodium chloride, an essential nutrient for all humans and most life. And adding chlorine to drinking water was the biggest advance in the history of public health, and 85% of our pharmaceuticals are made with chlorine chemistry, and 15% have chlorine in them. So I suggested perhaps they decide on a somewhat more nuanced policy towards chlorine, but they wouldn't. So I left, thankfully, and decided to fashion myself a sensible environmentalist, basing my positions on science and logic rather than sensationalism, misinformation, and fear. Here's where I live today in the beautiful valley of Comox on Vancouver Island. It's an absolutely fabulous place for nature. That's a glacier, the Quinish, that still exists in this rapidly warming world, just a little bit more than halfway to the North Pole from the equator. So it's still cold there. Canada is the coldest country on Earth at minus 5.35 C average over the year. And Canadians are more worried about climate change and global warming than the people in India, China, Brazil, Nigeria, and Saudi Arabia combined. This fake invisible catastrophe and threats of doom thing isn't just some sensationalist title. This is actually what I consider to be a genuine scientific hypothesis. I call it the unified theory of scare stories. In physics, there's this holy grail called the unified field theory, where all the physics equations come in sort of like a EMC squared on steroids, come together as one equation. It may never happen, but it's a nice idea. But this is the unified theory of scare stories, and it has happened. All the predictions of catastrophe today are based on things that are either invisible, like CO2 and radiation, and whatever's supposed to be in GMOs that bad is bad. It doesn't have a name. It's supposed to be a thing. All things have names, but there is no name for the bad thing in GMOs. Therefore, it is not only visible but invisible, but it does not exist. That is a logical conclusion. Or very remote, like polar bears and coral reefs, or both, like coral reefs, remote and rather invisible. All scare stories are based on things that stories and narratives can be made up that the average person cannot observe or verify. The two first steps in a scientific discovery are observation and verification. The next one is replication, where people outside, you give it out and say, look what I found, see if you can do this, and if it replicates, you're verging on a theory. And so this makes it possible for politicians to buy science, almost all of which is paid for these days by the government, our money, to buy science from scientists that then goes on the megaphone of the media and the activists and brainwashes the public into thinking that CO2 is the control knob of the climate, and they can't see a control knob anywhere because CO2 is invisible. That's what I'm talking about. Okay, well, this is a rather complicated graph, but what I just want you to look at is what's inside the big circle there. That is the time when CO2 and temperature were in opposite to each other in the terms of the direction they were going in for 200 million years. That would hardly be a hard, fast cause-effect relationship. I like going back in time and looking at what happened before when we know it from ocean sediment analysis and stuff. So there's another ice age further back, which was also during a period of great warmth. And then there's now, where it's true CO2 has been declining steadily for 150 million years, but during that time, the temperature went up to the pretty well highest it's ever been in the history of modern Earth, and the Eocene thermal maximum there, the top blue line, and then they sort of came in sync with each other. But unless cause-effect things are in pretty good sync with each other, you can pretty well be sure that they're not lockstep cause-effect relationships. And there you have it. This is what would have happened if we hadn't come along. There's the CO2 for the last 150 million years, the blue line. There's the present level that we've raised it up to since it went down to nearly the death of plants at 180 ppm during the most recent major glaciation 20,000 years ago. That's the lowest it's ever been in the history of the Earth. It's almost impossible to imagine that there was any other time when it was lower than 180 ppm. So it was constantly going down. Why was it going down? Almost entirely because of these things. Calcifying marine organisms learned to make armor plating for themselves about 450 plus million years ago in the sea, combining calcium with carbon dioxide, making calcium carbonate, which is limestone, chalk, and marble, all the same forms of the same compound. And that is what has depleted the climate, the atmosphere and the seas of CO2 over the ages. Life invented a process which was wonderful, making a soft body's armor plating, like a clam and a coccolithophore there on the very far left and a foraminifera on the right. They eat those little coccolithophores. They fit through those holes in their shell. And the coral reefs are responsible for 50% of the removal of carbon dioxide from the oceans and putting it on the bottom of the sea where it turns into carbonaceous rocks. Limestone is a life origin rock. It didn't come out of a volcano. That's why. Now, I can't spend a lot of time on this, you see, because I got other things to talk about. Here's the 50 million year cooling period that was in that first slide I showed about temperature. This is the period during which it went from the Eocene thermal maximum to the Pleistocene ice age. We are at the tail end of a 50 million year cooling period, and they say it's too hot. We are at the lowest level of CO2 in the history of the Earth, and they say it's too high, right? That's where we are, in the exact opposite of what people should understand. Here's the last 5.5 million years from marine sediment analysis. You can see the beginning of the Pleistocene ice age there. At first it was in 41-year cycles, the major glaciations, in sync with the Milankovitch cycle due to the tilt of the Earth. And then it amazingly switched to the 100,000-year cycle, which is the change in the Earth's orbit shape from less to more elliptical. And there have been 45 of these ups and downs through the Pleistocene Ice Age. And as you can see on the right-hand side, the glaciations are still getting colder. We are only 2.6 million years into the Pleistocene Ice Age. The preceding Ice Age, which ended 250 million years before this, had lasted, it's the Karoo, had lasted for 100 million years. We don't know why these ice ages happen. It may be due to the movement of the plates, the tectonic plates and the ocean currents that result. That's just a hypothesis. We don't know why. And this one is not over yet. Here's the last 4, including the present one. Note that all 3 of the previous interglacial periods, which have names, were warmer than this one. And they say this one is too hot for life pretty soon. No. It is colder now in this interglacial period than it has been through most of the interglacial periods in the Pleistocene Ice Age. And here's the only graph I'll show you that's recent. This is the longest temperature record by a thermometer in the world, continuous temperature record from central England. And as you can see, in the early part there, speaking of long periods of warmth, there's a 35-year period there right at the beginning from 1680 or so to 1730 or something, where that is a more rapid and longer warming than has occurred since we started burning fossil fuels. That was coming out of the Little Ice Age, which was focused around 1700. And as you can see, the exponential growth in carbon dioxide has hardly shown up in the temperature curve. Okay. Polar bears would not exist if it weren't for climate change. They're saying they're going to disappear because of climate change. But how did polar bears get here? They evolved from the Eurasian brown bear, which is our grizzly bear, only the grizzly bear came here much later than the polar bear evolved from the Eurasian brown bear. It was falling into the Pleistocene that caused the Eurasian brown bear to experience divergent evolution and turn into 2 species, because some of them started going out on the ice that was forming on the Arctic for the first time in 200 million years and hunting for seals. Eventually, as the ice retreated every year away from the Russian coast, the Arctic population became isolated from the terrestrial population in northern Europe and Russia, and they began to diverge into 2 different species. That is why there would be no polar bears today if it weren't for the Pleistocene Ice Age and the change in climate that occurred going into it. Here's the picture that was in National Geographic not long ago. This is what climate change looks like. It took them 9 months to retract that statement and replace it with, well, yes, it is true that starvation is what most polar bears are dying from, and that's probably caused by climate change and lack of food and all that sort of stuff. No, polar bears die of starvation because they are a top predator and nothing kills them. Right? Even if a big animal came to try to eat this guy, he'd cuff it away and kill it real quick with his front paws, because they're a big animal. They're the biggest animal in the Arctic. So this is such dirty pool, but this is what they do. Here is the ice in the winter last winter. Maybe it was this winter. I can't see what year that is, but these are the most recent pictures. See, the Arctic ice in the winter covers the entire Arctic Ocean and then some. They never tell us that. That's when the bears go out there. There is no loss of ice for the bears when they go out there. It's still covering the entire Arctic Ocean. Then you have a really nice picture of a polar bear eating a seal. I don't understand why they don't eat the entrails. No one's been able to tell me that, not even Susan Crockford. I asked her to see if she knew. So there must be a reason, because they're nice and juicy. That's the liver and the heart and the intestines there that they've left on the ice. There's the food chain of the Arctic Ocean, showing how the plankton makes the krill, makes the fish, makes the seals, makes the bears. So in the summer, when the ice recedes, and this year it hasn't receded anywhere near as far as it has done in the past years, down back to 2007 or so. It's actually growing again in the summer, not shrinking as much rather than growing again. But see all that open ocean? That's where the sun can shine on the ocean and make plankton, to make krill, to make fish, to make seals, to make bears. So it may be that the reduction of summer sea ice in the Arctic is actually beneficial to the growth of the bears. Here's the latest population estimates for polar bears compared to 1973. What happened in 1973 that nobody ever tells you about? A treaty was signed by all polar nations ending the unrestricted hunting of polar bears, which was happening far too much. It was getting so rich people could easily get up there in a plane and hire an Inuit guide and get a couple of polar bear rugs for in front of their fireplace. So that's why the bear population has grown, and maybe also because the sea is getting more nutrition from the sunlight now. This is what the Inuit people are saying about the polar bears today. There's too many bears. They're invading their homes, they're killing their people. They don't like to have to go to a funeral of a person who's been killed by a polar bear. They used to control the polar bears when they were living there on their own for 3,000 years. They used their dogs to surround the polar bear, and then they speared them. Because there got to be too many then too, I guess, for their liking. But the point of the matter is, they have drafted a polar bear management plan in Nunavut, which is the territory of Canada that has no trees and has all the polar bears. We have more polar bears than any other country around the pole by far. And they've published this management plan over 2 years ago, and only one publication wrote about it. A publication in Nunavut, in a town of 1,200 people. So much for the polar bear extinction myth. But the media in the mainstream of the United States and Canada did not report the fact that the Inuit thought there were too many polar bears and had to pass a plan. You've all heard of the Great Sea of Garbage, twice the size of Texas in the middle of the Pacific Ocean. Here's an illustration that actually shows two Great Pacific Garbage Patches, but of course it's a totally fake image. Someone just drew this. And here's another one. This is what you find on the internet in images for the Great Pacific Garbage Patch. That they say it's twice the size of Texas. That looks nearly as big as the lower 48 to me. You know, and here's another one, half the size of South America. That they've just, I don't know what they threw on the map there to make it look like that, but it's brown, whatever it is, and probably BS, as far as I can see. Here is an actual, as the arrow points there, this is part of the Pacific Garbage Patch. I noticed there were mountains in the background. There aren't a lot of mountains in the middle of the Pacific Ocean. I noticed this. No one else noticed this, right? This is from the Japanese tsunami that killed 20,000 people. It's kind of irreverent to say that this is the Great Pacific Garbage Patch when in fact it's the result of a huge calamity of nature, of an earthquake, as if we can stop those with our climate change policies. Here's a real composite photograph from a German satellite where they're trying to get a good all-around picture. They take it all year, so they get everywhere with no clouds on it. You can see the Hawaiian Islands quite easily, and Fiji, down lower off Australia there, but you can't see no Great Pacific Garbage Patch. One guy said to me after I gave this talk, it's just the clear plastic. That's why you can't see it. A plastic expert just emailed me when he saw this, and he said, actually, all the clear plastic has a density of 1.2 and sinks to the bottom. So that does away with that theory, as if it needed any further doing away with. Then someone else said, it's just below the surface, as if every piece of plastic has a buoyancy compensation device on it. Sorry, that's not going to fly. Oh, but it's microplastic. Oh, you mean it's invisible. And it's in the water column. It's not on the surface, the Great Pacific Garbage Patch. It's microplastic in the water column. A top-notch fisheries biologist from the Pacific Biological Station in British Columbia went out into the Pacific to figure out how much microplastic there was in the water column. He had a great big instrument with a net in it with real fine pores, so he could get he found nothing. He thought he had made a mistake because he found no microplastic in the water column. So there you go. What you do find out on the ocean after 48 days of searching is a bunch of scattered around discarded fishing gear. Now, it's not good to have discarded nets in the ocean because they can catch fish. It's because of its shape, not because it's plastic. There should be an international program to make it so that fishermen will bring their discarded, their damaged fishing gear back to the dock, because that's the only reason they throw it over. They don't want it on their boat. There's almost so much room on a boat. They want room for fish and the good nets that they're using. They don't want a bunch of garbage on their boat. It takes up a lot of space. So that would be a good program for the plastics industry, is to work with the international fishing community to figure out how they could get a little bit less of this in the ocean. But it's not hurting anything. You see, this Greenpeace says this crab is trapped in the cup. No, it's using it for a home. This is habitat. This is shelter. And the beauty of plastic compared to wood floating in the ocean is there's no wood that is shaped like a home, right? There's no wood that is like a cup or a container. If you have a container with a narrow hole in it, like a bottle that had a cap on it, all kind of things can go in there and nothing can get them, right? So a plastic on the bottom, piece of plastic on the bottom with a hole in the top makes habitat, especially if it's a muddy bottom where there's no other habitat. So plastic in the ocean is actually superior to driftwood in that some driftwood actually is quite toxic. Western red cedar, for example, is full of toxins to prevent bacteria and fungus from eating it, whereas the plastic doesn't have any toxic in it. I mean, that's not a big deal, but it's the truth. This too shows how good plastic is in the ocean. These are pelagic barnacles growing on a tiny float. That's my photograph on Grant Bay on northern Vancouver Island. This is common. These wood and plastic comes ashore with all kinds of life on it, especially pelagic barnacles. Why do we wrap and package all our food in plastic? Because it's toxic, that's why, right? No, it's because it prevents it from being contaminated by things that are toxic or dirty or whatever. That's why. No one's figured out a better thing to package food in than plastic. That's because it's the best thing to package food in, because it's non-toxic, lightweight, and all kinds of things. Here's my least favorite person, Sir David Attenborough. He says, he wrote The Secret Life of Birds. He did a huge BBC thing on birds. He doesn't seem to know the word gizzard. All birds have two stomachs because they can't chew. They have no teeth. Therefore, they have to swallow their food whole. They have two stomachs, one which is a stomach like ours with acid in it to digest soft stuff. Another one which is a muscular stomach that can grind the food. And in order to grind the food, it needs a grinding material. Land birds use pebbles all their life. The parents feed the pebbles to the chicks when they can't get out and do it for themselves, and then the chicks, all through their adult life, take in pebbles, because the pebbles wear out. It's such a grinding process. I don't know how many of you know what a ball mill is in mining, but it's a great big circular thing that turns, and they put the ore in there that hasn't been crushed yet, just after it's been blasted into big and small pieces. And then they put huge iron balls in that ball mill. That's why it's called a ball mill. And those balls just beat the crap out of that ore in there. And that is how they grind the ore. And a bird's gizzard grinds the food in exactly the same way. Now, this girl here, working for David Attenborough, is showing a plastic film bag claiming that it was fed to an albatross chick for food, mistaking it for food. Same thing here. She says that great big plastic glove there was fed to an albatross chick as food. These are lies. Here's what albatross feed their chicks. It's not food, so it's not feeding. It's giving it to them so they can use it as a digestive aid in their gizzard. Scientists that I've worked, Willie Soon and I and the Connolly family in Ireland have worked on this and published on it, about to be published on it, I hope. Scientists have been studying this for 50, 60 years. At first they were afraid that it was bad that the plastic was in the gizzard. It's only ever a minority of materials. They use pumice, they use driftwood that's the right size, they use nuts, round, hard nuts, and they use the squid beaks. After they've digested the squid, they keep the beak in their gizzard because it is a hard object. And all of these wear out, though, over time, and so they have to keep doing it all their lives. And the parents have to feed the chicks. The parents feed their chicks a much larger amount of plastic than they have in themselves because the chicks don't have to fly. And they want those chicks to fly now, soon, so we don't have to keep bringing you stuff. So they put a lot of stuff in the gizzard so it grinds up the food quicker and faster and makes them fatten up quicker. But that's what they put in. Not this. These are many staged pictures that have been created and put on the internet. There is no what I said about the scientists, they found out long ago that these plastic bits were not causing harm to the birds, that in fact they were just like any other digestive aid. And the Smithsonian and David Attenborough and Greenpeace say they're killing the birds, they're poisoning the birds, they're this, that, and the other thing. Even the Smithsonian Institute is buying that. I've got it all in my book. This is garbage. They put that stuff in there to make it look like that chick had that much plastic in its body. The gizzard isn't even that big. That would fill the whole gizzard and then some, right? And okay, I come now to what should we really do with plastic waste, and not just plastic waste that isn't suitable for recycling, like film bags and stuff. What should we do with it rather than put it in a landfill? And not only that, what should we do with the other combustible waste? Wood and paper. Wood, paper, and plastic are all of life origin. As a matter of fact, virtually everything on the earth that will burn was not here when the earth was formed. It's of life origin. If it was here when the earth was formed, it was so hot it would have burnt it. Right? So what we can do with all of the combustible waste is put it in a waste-to-energy plant. There's one at the Minneapolis-St. Paul area. There's one on Long Island, but there's very few of them in the United States. And the United States landfills more than 50% of its municipal waste. As you can see, and in this is a state-of-the-art machine. They even recover the metals, like if there's nails in the wood, waste wood from demolition. Nobody wants a piece of wood this big that's got 6 nails in it, right, to recycle. So that should go in there. And so should all the plastic that you're throwing out into your garbage now, because it isn't suitable for recycling, and all the paper that's dirty, like pizza boxes and stuff like that, should all be going in there. Europe makes 4% of its electricity. The entirety of the EU makes 4% of its electricity with these plants. And if you look here, you will see on the left, there are many countries that have virtually no landfills. And they are the more enlightened Western European countries. And you can see the green is the recycling rate. Now, Greenpeace and them say you should not allow these waste-to-energy plants because then they'll burn everything and they won't recycle anything. The recycling rates are higher in the countries that have waste-to-energy plants because they separate it perfectly. They know what can be recycled and they know what can go in the waste-to-energy plant, and they make 4% of their electricity and something like 6% of their district heating, something we could use a bit more of around here. But as you get into the Eastern European countries, you see they have a far higher level of landfill and virtually no waste-to-energy, none in some of them. There you go, that's waste-to-energy, and here's what China's doing. This is the world's largest waste-to-energy plant being built right now. Those are solar panels on the roof, which is kind of cosmetic, because really the power is coming from the municipal waste that's being burned in there 24/7, 168 megawatts. So this is, like 5 of these would make a pretty big nuclear plant, the same equivalent. Well, and gas plants are in that sort of range, I think. Would everyone agree that that's a reasonable big gas plant, 168? Coral reefs are dying around the world. How many of you have heard that the Great Barrier Reef is dying? Everybody. It is not. It is Actually, there is more coral coverage there this year than there has been any year in the last 30 or 40 years since they started really looking at it. But here's the story. And then we wept. Little emotional touch there. 93% of the Great Barrier Reef is, practically dead. 93% is bleached. Great Barrier Reef suffering. None of that says died, does it? That's how clever the media is, those crafty journalists. They didn't actually say it had died. Practically dead is not dead, right? Now the Great Barrier Reef is terminal. This is the next year, 2017. Great Barrier Reef at a terminal stage. Scientists despair at the latest bleaching data. Great Barrier Reef, this is my favorite, is in its final terminal stage, as if there are other terminal stages before the final one. There's the first, second, third, fourth, and final terminal stages. I hope I don't have to go through that many of them. Next year, hardly ever any press at all, but the Great Barrier Reef is now definitely not dead all of a sudden, right? Significant signs of recovery. Showing signs of recovery. Coral reefs show remarkable ability to recover from near death. Right? Well, some people do too. I don't know how remarkable it is in people, but some people do recover from near death. I don't know where near death begins and ends. Coral bleaching is not death. Coral bleaching is a natural phenomenon in coral where they reject their symbiont phytoplankton, which they have taken in. Coral polyps are an animal in the same family as jellyfish. They are transparent, like many jellyfish. So when the colorful phytoplankton that give them their color of green and blue and orange and purple are ejected, they eject them sometimes when it's hot, they reject them sometimes when it's cold, and then when the event is over, they take new ones in. And they almost never die from it. And the ones in the Barrier Reef didn't die from it either. Shouldn't scientists and eco-reporters know this? That bleaching is not death? And that usually reefs recover from mass bleaching events? Yes, they should know better, but they don't care to. No one ever said that through this whole thing. Now let me tell you a story. The world's warmest seas are in the Coral Triangle, where I have snorkeled on 2 week-long trips in the Papua area and in the Bali to Flores, where the Komodo dragons are, that archipelago of islands on the south of Indonesia. I've been snorkeling all my life. I've seen coral reefs get damaged, and I've seen coral reefs recover. And the main story is, though, this is the warmest ocean in the world and has by far the highest biodiversity of corals and coral reef fishes. What does that tell you? It tells you that as the 50 million year cooling period has progressed, corals have shrunk in their range in the seas into where the main biodiversity is only in the warmest ocean left. The reason that ocean is the warmest is because it's protected by South Asia and Australia from the warm waters to the north and south. The Great Barrier Reef receives colder waters. It's nowhere near as warm and has only half the biodiversity or less of the coral reef. You should really go there. Here's what it looks like on charts. This is a peer-reviewed paper. Up on top, it shows the biodiversity, the number of species of all taxa, 13 taxa, right, of all different types of fish and coral reefs and deep sea fish and shore fish and everything. Look at the area around Indonesia. Then come down and look at coastal fishes, and then come down and look at corals. The Caribbean, which is the second warmest ocean in the world even today, has lost 50% of its coral species during the descent into the Pleistocene. And they are claiming that this doesn't prove that the oceans can't get too hot for corals anytime soon. Corals would be growing across a much wider range if the oceans were as warm as they were in the Eocene thermal maximum, when the whole world was warmer than it is today, right to the poles with no ice, but in fact tropical forests on the Canadian Arctic Islands and Antarctica. Go there. I took these pictures. I took thousands of pictures over the 3 expeditions we've had snorkeling, one with the humpback whales in the Caribbean, north of Dominican Republic, where they bring their calves. They come down after the East Coast and go down and bear their calves down there. And because they have a 1-year gestation period, the males are just waiting for them to quit nursing their calves so they can mate with them. So it's quite a scene, and there's 5,000 of them there, of big humpback whales leaping up in the air and with their babies down on the bottom, and it's only about 30, 40, 50 feet deep, so you can't dive there, it's against the law, but you can snorkel there and go there. There's only 2 boats allowed to go out there with about 20 people each. This is just a little bit of it. That red thing is I forget the name, nudibranch, and that's a giant clam, the blue guy down there, and a beautiful little reef fish and the corals. It's the most biodiverse oceanic environment on the planet. Well, getting towards the end of the examples here, this is a walrus which Sir David Attenborough said is committing suicide by jumping off a cliff because there's not enough ice in the sea. I don't know quite how those 2 things are connected, but the real reason it was jumping off the cliff, and this has come out absolutely with no doubt, because I'll show you how they got up there in a minute, but this is why they were jumping off a cliff. What would you rather do? Be eaten alive by polar bears or jump off a cliff hoping you might survive? But the polar bears, most of them didn't survive, and the polar bears just waited for them to jump off the cliff, walked down by the shore, and ate them all. But at least they ate them when they were dead. Here is the colony of walruses. See, there's so many of them now because just like with the polar bears, they've stopped allowing any hunting of them to any extent. Like the Inuit people hunted them extensively, and then other people came up into the Arctic and hunted them too. And so this is overcrowding. Now, Attenborough says they go ashore out of desperation because there isn't enough ice for them to go out on. If that's true, why is this called a polar bear sanctuary by the Russian government? They don't go up there out of desperation. They go up there because the ice has receded way to the north in the summer. And when the ice recedes, they have to go on the land if they want to haul out. Polar bears do like eating live walruses. They know that. They're one tough animal, the polar bear. Sometimes they get them and sometimes they don't. Now here is why they can't go floating out on the ice to the north of the coast of Russia, because polar bears are bottom feeders. They use their tusks to dig clams and other organisms in the mud in the water. They can only dive 300 feet maximum. Mostly they dive 150. So if the ice recedes to where the ocean is 1,000 feet or 6,000 feet deep, way off north, they can't go on the ice there. They are a coastal species. And the home isn't on the ice, it's in the water like it is with other seals and sea lions and stuff. That's what they are. But they like coming out on the land, just like seals and sea lions do. But they are a bottom feeder similar to David Attenborough's camera crew and himself, right? That's his camera crew shown there. They know they're bottom feeders. They know why there's no ice there. They know the polar bears caused the walruses to jump off the cliff. But he just went to Davos, to the World Economic Forum meeting, and made them all cry their eyes out about the story of the walrus suicides. I'm not kidding you. Oh, there's one more section. This is Chernobyl. They say nuclear energy is too dangerous and should be banned. Only one nuclear accident has ever caused death to humans, Chernobyl. 3 Mile Island was just an incident. No one even got enough radiation to even be thinking about it. It was just a scare, and of course the media made it even scarier than it really was. Fukushima, no one died from radiation. That evacuation should not have been done, and the radiologists knew that. The people from the Radiation Effects Research Foundation in Hiroshima and Nagasaki, which was set up by MacArthur and the Japanese after the bombings to follow the life history of people who survived against people who weren't there and didn't get exposed to radiation. It's another whole story. But it is very clear that it was not necessary to evacuate those people when they knew exactly what their radiation exposure was. 2,000 people died because of the evacuation. They moved IUC wards into gymnasiums. People died because they didn't have the equipment to keep them alive anymore. That's what happened there. Very few deaths emerged out of this, but Chernobyl was a reactor design that should never have been built. It had a positive void coefficient, which nobody knows what it means. Even me hardly know what it means. It means it wasn't a negative void coefficient, which is good, because then it can't blow up like a nuclear weapon. Chernobyl was not a meltdown like Fukushima and 3 Mile Island. Chernobyl was a nuclear explosion, a slow one, but a nuclear explosion, and blew a 2,000-ton concrete top off the reactor, and the graphite moderator, which was many hundreds of tons, caught on fire, and it took firefighters 10 days to put it out, being exposed to the core of the reactor. And it's amazing how many of them didn't die from doing that. Again, the evacuation there was unnecessary too. That place has turned back into a wilderness area in the meantime, full of wolves and wildlife and everything. They could have stayed there, just not grown food there for a period of maybe even decades. But they went to a place in Kiev where they didn't grow their food either, in large tenement blocks, and the social conditions that occurred there of family breakdown and drug addiction and alcoholism and beating and not looking after your kids properly and everything was way worse than anything that would have happened if they'd been left in their country homes around Chernobyl. So this is modern nuclear reactors in South Korea. These 2 reactors can service 4 million homes. They like to make their reactors look pretty. I wish we would do that on our side of the ocean. Here they just make a big concrete thing and let rust come down on it, and they don't paint it up. They put marble on the walls inside these things because they want them to be considered like a good, nice thing, aesthetic. Here it's just bare concrete. And I really like their program in Korea. They produce 1/3 of their electricity with nuclear, as do, thank you, Jim, as do, that's just a 10-minute warning, I'm going to be fine. But anyways, that's a nuclear reactor. The truth is, here is how much energy is used in the world and what it's used for. And as you can see, fossil fuels are about 85% of it. And we're told to go to net zero in a short time. And we're also told we can't build nuclear plants to replace the fossil fuels, which would be really the only way we could possibly do it in a sane way. Buildings consume 40% of all energy. Nuclear energy could provide virtually all of that. You might want some gas for peaking or hydroelectric in the mix, but because they can both be turned up and down easy. They actually will be able to make nuclear plants that can be ramped up and down too. So you could probably do the whole 40% of this energy, which is now being primarily produced with fossil fuels. You could replace all those fossil fuels with nuclear electricity. Everything stationary in the world could be run with nuclear energy. If it doesn't move, it can be hooked up to an electric cable for heat or electricity. That is a fact. All ships, including oil tankers and cargo ships, could be powered by nuclear propulsion. If you can run 5 nuclear icebreakers in the Arctic, which Russia does, or if you can take a submarine underwater with 100 nuclear missiles on it for 3 months, you can probably run a boat with it. Yes, you can. They've been building nuclear propulsion ever since nuclear propulsion was invented for military ships. It would not be a problem. You can electrify every train in the world with nuclear and go to maglev at 500 kilometers an hour and make it so you didn't have to make short flights, because you wouldn't then have to go to the airport and wait in security and all the stuff you have to do that makes it longer to go by plane than it does by a 500 kilowatt kph jet plane. So there you have it. Okay, quickly. This is Mauna Loa, the CO2 going up. This is its effect. This is NASA. This is the Australian Commonwealth Science and Industry Research Association organization. They all show this up to 30% increase in biomass. Guess who's producing the biggest increase in the greening of the earth? China and India. Because they burn the most fossil fuels and therefore are producing the most CO2 to make the crops and forests grow, and they're producing more food, putting that CO2 into a cycle. They're producing more food, thus greening the earth with fast-growing crops in agriculture. They are the winners, not the bad guys, when it comes to CO2 emissions. It's hard to get that paradigm around in your head, I know, because everybody's saying, well, China's the worst anyways, so why are we doing it? That's not the way to look at it. The way to look at it is that China and India are doing this. Now, I'm not saying we shouldn't cut fossil fuel use in half. I am saying we should. Not because of CO2, but because we should conserve it for things that can't be done with anything else. You can't run a nuclear reactor, you can't run an airplane with a nuclear reactor, right? So we should conserve the fossil fuels. With a nuclear reactor, you can turn 100% of the coal into liquid fuel. Sasol in South Africa is making liquid fuel, has been for years because they were embargoed and didn't have any oil or gas then. They're making liquid fuel from coal, but they're making it with energy that's produced by coal. Right? So half of it's used for the heat, for the processing, and the other half of it is used to hydrogenate the third that's left. So they only end up making 1/3 of the coal into liquid fuel that way. If you used nuclear energy, you could make 100% of the coal into liquid fuel. So it is imperative that we smarten up on this and build another 4,000 nuclear plants. There's 440 now. They aren't hurting anybody. Nobody in Canada or the United States with over 100 nuclear power plants has ever been injured by a nuclear power plant. What is the matter with these people? One of the problems is the nuclear energy industry, and this is why I quietly pardoned myself from my position in it in 2012 after 6 years of working with Christy Todd Whitman as co-chair of the Clean and Safe Energy Coalition. They will not get off the message that it's because they don't emit CO2 that we should accept nuclear energy. In other words, they throw the fossil fuel industry under the bus in order to make themselves look good, and I do not agree with that. That is ridiculous. Fossil fuels are the most important energy for making civilization what it is today, for causing us to live longer, live better, and all the other things. Medicine's important, technology's important, but fossil fuels are the energy. And energy and food we need today. We can order something from Amazon that's a material thing, like electronic device, and we don't care if it takes 2 weeks to get it, right? Material and energy are different that way. Energy is needed now to power our bodies and all the rest of life, and to power all the machineries we have that are needed every day. And that's what's happening now with this supply chain thing and all kind of stuff going down. Fossil fuels are 100% organic. As in the scientific meaning of the word, organic chemistry is the chemistry of carbon, the chemistry of life. All other elements are called inorganic chemistry. Organic, as it is used with food, is purely a marketing slogan. It is not a scientific term. So we should tell people that fossil fuels are organic. They were produced with solar energy from the sun, combining water and CO2 into sugar to make glucose, which is the energy for the entire food chain of life, including us. It's the most important process on the earth, photosynthesis. And it made the fossil fuels, which, when burned, produced the water and carbon dioxide that they were made with. And the important thing to note is that all the CO2 we are putting back into the atmosphere with our burning of fossil fuels and our production of concrete, cement, from limestone, which is about 5% of our CO2 emissions, all of that came from the atmosphere in the first place, and we are only putting it back where it came from, where it was fertilizing life through the history of life, when it was 5,000, 10,000 ppm. Through an ice age, CO2 was 4 times higher than it is today. So what are they talking about? How could civilization become so stupid as to think the exact opposite of what is the truth on both CO2 and temperature? Fossil fuels are still, with all we've used already, and there's lots left, are the largest solar storage battery on the earth. That's what they are. They are never going to make a battery out of lithium that is as much as what there is in the fossil fuels from solar energy. They'll never make enough wind and solar energy to meet the amount of energy there is in the produced from life, fossil fuels. Wind and solar technology is a parasite on the larger economy. There you go. Thank you very much for listening.